Have you ever wondered why Mercury, the smallest planet in our solar system, orbits so close to the Sun? It's a question that has puzzled astronomers for centuries. But the answer lies in the intricate ballet of celestial mechanics, a dance choreographed by the invisible hands of gravity. Mercury, named after the Roman messenger god known for his swift speed, is a tiny rock of a planet, dwarfed by its gargantuan neighbors. Yet it holds the distinction of being the closest planet to the Sun. This proximity isn't by chance, but by design, a design dictated by the Sun's overwhelming gravitational pull. Gravity, the unseen puppeteer of the cosmos, is the force that binds all celestial bodies together. It's what keeps our feet planted firmly on the ground and what tethers the moon to the Earth. But most importantly, it's what compels Mercury to maintain its intimate dance with the Sun. The Sun, with its immense mass and consequently its potent gravitational pull, exerts a powerful tug on Mercury. This tug is so strong that it has drawn Mercury into a tight orbit, forcing it to circle the Sun every 88 Earth days. That's nearly 4 times faster than our own planet's annual journey around the Sun. Mercury's close orbit is a testament to the Sun's gravitational might. The Sun's gravity is so powerful that it has pulled Mercury into a near-perfect circle, a rarity among planetary orbits which are typically elliptical. This circular orbit is what enables Mercury to maintain its speedy pace, twirling around the Sun at a velocity of nearly 50 kilometers per second. All this means that from Mercury's surface, the Sun appears 3 times larger than it does from Earth. Imagine a sunrise that's thrice as grand, a day that's thrice as bright, and a sunset that's thrice as breathtaking. In this cosmic dance, Mercury twirls around the Sun at a dizzying speed, unlike any other planet in our solar system. This is the dance of the cosmos, a dance that's been ongoing for over 4.5 billion years, a dance that's set to the rhythm of gravity. To understand Mercury's relationship with the Sun, we need to travel back in time, to the very birth of our solar system. Imagine, if you will, a vast cosmic cloud, a nebula, filled with gas and dust. This nebula, under the influence of gravity, began to collapse onto itself, creating a spinning disk of material. At the heart of this disk, a protostar, the Sun in its early stages, was forming. As the protostar grew hotter and denser, it ignited into a full-blown star, our Sun, pushing a burst of energy outwards. This energy swept away much of the lighter gas and dust from the inner regions of the disk, leaving behind only the heavier elements. Now, let's shift our gaze towards a specific region of this disk, a region close to the newborn Sun. Here, in this hot and turbulent environment, the birth of Mercury began. Mercury started off as a collection of planetesimals, small chunks of rock and metal. These planetesimals, drawn together by gravity, began to collide and merge, growing larger and larger over millions of years. The heat from the nearby Sun baked this growing planet, causing lighter elements to evaporate and leaving behind a world rich in iron and other heavy metals. This hot and heavy composition is what gives Mercury its small size and dense structure. It's the smallest planet in our solar system, yet it's also the second densest, right after our own Earth. Mercury's close proximity to the Sun also influenced its lack of atmosphere. The Sun's intense heat and solar winds stripped away any gases that may have clung to the planet's surface, leaving it exposed to the harshness of space. So you see, every characteristic of Mercury, from its composition to its size, was shaped by its close relationship with the Sun. A relationship that began in the swirling chaos of a young solar system, in the heat and dust of a newborn star. So, Mercury's close relationship with the Sun was sealed from the very moment of its birth. Living so close to the Sun is not an easy task, even for a planet. Mercury, our solar system's smallest and innermost planet, has a tough existence. Its proximity to the Sun has shaped its environment in ways that are vastly different from the other planets in our cosmic neighborhood. Imagine a life under a blazing sun, a mere 36 million miles away, where daytime temperatures can skyrocket to 800 degrees Fahrenheit. That's hot enough to melt lead. This intense heat has dramatically shaped Mercury's landscape. The planet's surface is a stark, barren terrain, pockmarked with craters from billions of years of meteorite impacts. Unlike Earth, Mercury doesn't have a thick atmosphere to protect it from these impacts. Instead, every meteorite that comes its way leaves a lasting mark on its surface, creating a history book of cosmic collisions. But why doesn't Mercury have a substantial atmosphere, you ask? Well, the sun's intense heat is to blame once again. Any gases that could form an atmosphere are quickly heated to such extreme temperatures that they simply escape Mercury's weak gravitational pull and dissipate into space. The result is an incredibly thin, almost non-existent atmosphere known as an exosphere. This exosphere is mostly composed of atoms blasted off the planet's surface by solar radiation. It's a constant battle of attrition, with the sun ceaselessly bombarding Mercury and stripping away its outer layers. This creates a harsh environment where no known life form could survive. Mercury's close relationship with the sun also means it experiences severe temperature swings. Its lack of a significant atmosphere means it can't retain heat, so while its days are blisteringly hot, its nights can plunge to minus 290 degrees Fahrenheit. That's a swing of over 1,000 degrees. Mercury's existence is a testament to the power and influence of the sun. Its fiery surface, its thin exosphere, its dramatic temperature swings, all are products of living so close to our solar system's star. Mercury's proximity to the sun has led to a harsh and fiery existence, one that is unique in our solar system. The sun's influence on Mercury is not just about heat and light. The sun's gravitational pull is a dominant force, shaping the very essence of this small planet's existence. It is a celestial dance of epic proportions, where the sun leads and Mercury follows. Let's delve a little deeper into this. As we know, gravity is the invisible force that keeps planets in orbit around the sun. But Mercury, being the closest planet to the sun, experiences this force in a rather extreme way. This results in a highly elliptical or oval-shaped orbit, rather than the more circular paths that other planets take. Now, this is where things get even more interesting. One would expect that Mercury, like Earth, rotates on its axis to create a day-night cycle. But here's the kicker. Mercury's day is not like ours. It's not even close. Thanks to a phenomenon known as tidal locking, Mercury's rotation has become synced with its orbit. Tidal locking, in simple terms, is when the gravitational pull of a larger body, in this case the sun, causes a smaller body, our Mercury, to eventually rotate at the same rate as it orbits. This means that one side of Mercury is always facing the sun, bathing in perpetual daylight, while the other side remains in unending darkness. This results in a day-night cycle that lasts a staggering 59 Earth days. Imagine it like a cosmic tug-of-war, with the sun and Mercury pulling on each other. Over billions of years, the sun's superior strength has essentially slowed Mercury's spin to a crawl, aligning it with its orbit. This is why Mercury has such an unusual day-night cycle. In this constant tug-of-war, the sun's gravity has a firm grip on Mercury, dictating its every move. It's a fascinating example of how the forces of the universe shape the worlds within it, and a reminder that even in the vast expanse of space, no planet is an island unto itself. As we gaze into the future, what lies ahead for Mercury? As we venture into the realm of the yet-to-happen, the tale of Mercury's future is a fascinating one. Our smallest planetary neighbor's relationship with the sun, the very star that has defined its existence, is set to undergo some dramatic changes. As the sun ages, it's expected to expand. This is a natural part of a star's life cycle. But what does this mean for Mercury? In essence, it's a bit like Mercury is living next to a ticking time bomb. As the sun grows, its gravitational pull will strengthen, and this will have significant implications for Mercury's orbit and overall existence. Scientists predict that in about 5 billion years, the sun will have expanded into a red giant. At this stage, its outer layers will reach out into the solar system, potentially engulfing Mercury. However, there are other scenarios to consider. Some experts propose that the sun's increased mass might cause Mercury's orbit to spiral outwards, saving it from a fiery demise. But even if Mercury escapes being swallowed by the sun, it will still face a harsh future. The intense heat and radiation from the expanded sun will scorch the planet's surface, turning it into a barren, lifeless world. The already thin atmosphere of Mercury will be stripped away, and any remaining geological activity will cease. This, however, is not the end of Mercury's story. Even in its scorched state, it will continue to orbit the Sun, a testament to the resilience of celestial bodies. For billions of years to come, Mercury will carry on its cosmic dance, a silent ballet performed in the vast emptiness of space. So, while Mercury's future might seem bleak, it's important to remember that it's all part of the natural life cycle of our solar system. And even in its final stages, Mercury will continue to offer valuable insights into the workings of our universe. In the grand scheme of cosmic time, Mercury's dance with the Sun is far from over.